It's called flow plus temp under the simulations, and there's a grasshopper and a 3D model. These um, right here. So those, if you open that up, it should be the same file that we had before, but it's set up differently. So um, again, in here, uh, it should work all the way as it's set up now. If we just change this to false and then hit this button. Nope, it's not. Um, Not working. Okay, so this thing again here is the grid. So it creates a grid like this. Um, these points are going in here. So these are the colliders. So I've selected a bunch of curves, the ground, and these walls as the colliders, which look fine. Um, and then this thing right here is like my version of the temperature source thing. Okay, so it's a little confusing. Let me see if I can get this to run first before. Um, there we go. Okay, you just have to click the reset button, this evaluate button. It'll load all these things in, and then if you click this button over here, after it loads, you can change this from false to true. And then if you click this button over here, um, it should uh, it should simulate with the temperature. Okay, so this is like a Rhino version of what's happening in Houdini, but two-dimensionally. So the way this works is uh, I'm just going to go through the sources with you. So it takes you got to click this reset button here, and then this button right here to reload all the sources, and then this button to get it started. But this has to be set to false in order for it to load. Yeah, the dam has to be on false. Like its damming is true. You just double click this. Okay. And so there are a couple of inputs here that are in order to set the sources, and then a few different types of controls. So this is again the collider takes a set of curves. This is the temperature field. So this right here goes in this A free. This is what area it's going to evaluate in terms of like um, calculating the simulation within. This stuff going in this A constant is going to be kept at a constant temperature. And this stuff going in this A source is going to be incrementally um, uh, adding something every time until it hits a target value. So um, this is a starting temperature right here, goes into the V free. This is the constant temperatures. You can just type them in here. And this is for the source temperatures, this is the target value. And then this is how much gets added each time. So basically, like the same, what I've done is I've put all of these curves for the walls into a constant, and I set them all equal to 10. This is in Celsius. And then for the source, I wanted the area outside of the building to be constantly getting colder. So I have an area like this, and that is and then I also have a heat source here. So there's one. I should not have my curves white. Very frustrating. Um, there's one source, and here's the other source. So those go in to this source tab. I just go set multiple curves. And then you also need um, the target temperature, and this is adding 100 degrees every time until it gets to 50, basically. And this is subtracting 5 degrees every time until it gets to 5. So a little confusing, but it's similar. This idea of I need to set this up differently in the future, but this is the beta version. And so in the future, I'll do it like Houdini, where it's like you can select a pull or an add. But here, instead of it being like that, they go into different channels. Okay, so this is that's how it works. Okay, and then this right here is another thing, and this evaluates whether something is inside of an area or outside of an area, and that has to do with whether or not what is the reference temperature that it's using to calculate whether air sinks or falls. So I have the inside is using a reference temperature of 10 and the outside is using a reference temperature of so requires putting things into the curves. Does that make sense to anybody? Very confusing. Um, I'm gonna see if I can uh uh we could try setting it up differently and seeing if it works. But um essentially all of those things are just being passed through the data dam and then into their target field. So if you look at this, it's a little hard to read, but basically the the U start is the input value for the velocity, and I have that as 0. The V is 0. This S is the collider field. And then um, all the way down here, I have different things set up. So what turns on the temperature is this on advect T button set to true. And then uh, remember I said Houdini always works in reference to a reference temperature. So mine can do both. It can work in reference to a reference temperature, and it can also look at every single spot in the simulation and compare the neighboring temperatures to that and decide whether something goes up or down based on that. And that's this uh, on local temp button. So, and then it can also average the two of them. So the two approaches. So if you turn off this on local temp button and play the simulation, it's working the way Houdini does based on like a, a global reference temperature. And if you turn on this on local temperature button, it's it's working based on it's comparing the neighboring things, but it's doing it with this weight. So if this is 0, it will be only local. So there are two different buoyancies here. So if you look in Houdini, if I go to the Houdini simulator, there's there's the buoyancy number right here, 6. And this is my buoyancy control. And this is the local buoyancy, and this is the global buoyancy. So if I turn up the local buoyancy to something enormous, and then I turn on this on local temp, and I play this, and uh, I drag this weight all the way up to, you can see it's going bonkers. So like that has to do with the fact that now it's using only the local buoyancy. And if I drag this down to zero, now it's using only the global buoyancy. So it's a question, honestly, of trying to get it to behave the way you expect it to behave. So when I'm like, what I want it to like sometimes, like you can see there's some weird things going on. And so like, what I would want to see is a uh sort of a stable field getting generated. And uh, in order to do that, I sometimes give it a slightly different percentage of the local or the global buoyancy, basically. And this is usually set, I don't know, something in the middle. So it has a little bit of an influence from both. Um, and then um, the only other thing is you can turn on the out temperature. That's what's on right now, seeing the out temperature. And also the um, uh, the vorticity I have off right now, but you could turn that on as well if you drag up the vorticity. Um, uh, it will get super swirly. So um, I would like everyone to start trying to set up some simulations in Houdini and Rhino if you haven't already, so that I can troubleshoot them with you. In terms of what these numbers all mean, I intend to next class go through the mathematics of it with you to some degree, so they make sense, hopefully, a little bit more. Um, but oh, um, okay. And you can also turn on the um the streamlines as well, and see how they also are being manipulated by the buoyancy. So this only works for sections, but theoretically it should be able to handle something that doesn't look like a flame like this. This is an extreme example, but um, I think we need to be trying to get it to have a section that we're trying to get to work in order to play with it. So I feel like next class, what I would like to do is maybe like everybody would have started on something and I can go around the room and sort of look at what you have and see whether or not I can help you troubleshoot it. So and we can start to work on that together. Okay. No, what I would like to have by the end of the semester is I'd like everybody to have uh like a two-dimensional one in the Rhino simulator and a three-dimensional one in Houdini for the buoyancy, for the and for the wind, and then a distortion of each. So like you will have the physical one in the wind tunnel. You'll have the um the buoyancy one in two videos in Rhino, one in Rhino, one in Houdini. The wind, two videos, and then you'll change something about the model and duplicate the simulation with the change. So see how it so you'll have a series of videos. That's the idea. Like the physical, the digital, uh, and then the adjusted version of them. So and I think what I'm hoping is that everyone will maybe you won't be quite satisfied with the way it looks, and we can also talk about like how you actually want to show it if there's things we need to work on in Houdini or additions we need to make to the Rhino code. For example, like if I don't have something in here that like moves points through it or something. I mean, you could imagine very easily like we could move we could move little, you know, flowers or whatever, right? Like through it. I'm just, we could do anything, right? So it's like slightly also about how you want to depict it. And we will work on doing that together. So um, next class is either going to be me going through math or it's going to be us meeting as to work on your individual things. And I think, um, I think depending on what seems appropriate. But after that, um, I would like to do that a little bit more. Okay. So the only other thing I want to say about this is I don't think I made it clear the first time I said it. If I this right here um is like uh there's Houdini has only one reference temperature, but mine has two reference temperatures for inside and outside. And that's because like if you imagine like whatever interior like is warmer than the exterior or vice versa, and so it could be very weird for cold air to be um colder than the reference temperature in one area, but warmer than the reference temperature in another. And you might get something where very cold air is still sinking outside if you try to set the reference temperature to deal with the inside, because the range is much smaller, right? So this works by taking a curve, just one curve that's representing the boundary of the inside, and you put that in here. And then this is the inside temperature, and this is the outside reference temperature. And anything, if you want to look at the field for any of these, you can drag them over here, and we can see um, that's just showing me the reference temperatures. It's showing me that, the inside temperatures here and the reference temperatures there. Um, does that make sense? Somewhat? Okay. All right. Okay. I wanted to wanted to there are a few things that I didn't get to in Houdini last time, and I would like to um try to give you the other tools that you need in order to do your own things. So um if we go um back to this simulation that we were working on, I think um also, you can download the one that I have if that's easier, so that you're not in a situation where it's not working necessarily for you. I want to show you a few things. So this on the server is um, it's this airflow setup here, airflow setup. And I want to upload a new one right now that um, uh, so in terms of outputting things and saving them. What I am doing is it's quite easy. Okay, so if you let me wait for this to open. If you go to this little button over here, oh no, what? Oh, um, like, and if you click this little button over here, this thing that says render flipbook, um, and you right click it, and you'll get this little box, okay, and it'll say flipbook to mplay. You want this checked, um, and then you can just you can just click it, and it should open up this window and just play the simulation. Um, and then uh, once it's finished playing, you can essentially just save it as an MP4. Okay, so we don't need to render anything. I think we can just um, use this mode. If we have time to get into rendering later, we can, but I feel like this is probably sufficient for our to make visualizations that are quite compelling. Okay, does that does anybody oh, because you don't have the right. Okay, thank you. Okay, that's helpful. Yes. Okay, so that's fine. In a second, I will. So once this finishes, okay, you can just go here. You can go export FMPEG, and you can save it as a video. Okay, so very very easy to output things. Sometimes, okay, sometimes when you are doing this, it won't open the flipbook window. And that is typically, if that happens, you have to go over here and go to this render preview it, this mplay thing, and check that. Just click listen for flipbooks, and then it will open the window. Okay, so you're right, it's not working, and that's because I have I have it file cached, and you don't have the file cache on your computer. So if you switch instead to this preview, then it will work. Okay. So this node, if you want a portion of the simulation to play quickly, like for example, like all the way up here, you make this big. Uh, like this is the pyro simulation, the airflow simulation, and then all of this stuff is display. So if I wanted this all the other stuff to happen quickly, to if I wanted to build upon top of a quick simulation, what I would do is I would do file cache. I would insert that here, and then I would click on this and I would go save to disk. And then everything above that will be cached, not in my RAM anymore, but on a file that's saved in my computer, and then it will play back quickly. So that is why it's not working for you, because you don't have my own file cache on your computer. Okay? So um okay. Um that's because you don't have the it's because you don't have the it's because you don't have the object loaded. Okay, so let's go. You got to download the object, um, and um, uh, I have another one, by the way, that doesn't have the objects that maybe would be better. Um, if um, I wanted to give you guys this also. I revised this again, which is actually what I want to go through with you. This one. Um, okay, but in order to get it to work, you have to download you have to download the um the test model to FBX, and then you have to go into the um you have to go into the building layer and load the file here in the test model FBX. And when you load that, it's probably going to give you an error message. And in order to fix it, you will have to uh change. I think there's an issue down here with the naming. You have to change this so it says 2 FBX. Yeah, so there's a simulation and then there's a building. So if you go into the building and you go to the file, there's a button over here that lets you load the geometry. And I don't know where that is on your computer. It's wherever you download this thing to. So um, what I want to show you is uh, last time um, we went through some things here, um, adding a temperature source, adding a density source, um, and we didn't go through this. We did not go through adding a velocity source, which I will go through. But we went through adding collision, adding a temperature source, and adding a density source. Um, and then what I didn't go through is sort of what's happening after that, which um, is the first thing is two things, which I think are sort of important, and they are um, um, this volume visualization node. I think I did go over this very close to the end, but I wanted to look at it again, and that is this right here. So if you go in here, um, this node is has two inputs, two different fields, and they are the mask, which is showing what area is displayed, and the color field. So this is showing the density, and then it's displaying the color field in the temperature. So if I wanted to, if I click over here, I can see all the fields that I have. So let's say I just want to display the temperature field as the border and show the temperature. Uh, it'll be like, it's going to be something like that. And I added this other field, which I didn't go through with you. This is just a blank field. I called it color for no reason, but it just lets me show the whole box. Okay. So you can see there's no mask going on. Um, and then it's displaying the temperature as uh, the the color field. But I could also display the velocity instead uh, through the density. Let me let this play for a little bit so we can see more of it. Is anybody is it working or not working for people? Seems to work. Okay, excellent. The box, I'm going to go through that in a second. It's just like a completely empty field that I'm using only to let me display everything. I don't know why I called it color. It's totally random. Um, but uh, so essentially, it's working the same way I added other fields. If you look here, there's um, a box here. This is the box that I call my bounding box. And if I go to my view and I show that bounding box, it's it's that box right there. And I named it a bounding box with a null here. And then I made a VDB from Polygon, um, and I called that color. And I actually, this is sort of wrong. I called this color, and then I scaled it and I just put it in a color source. And then in here, I have another field in here called color, which just loads a color into the color field. So it just to cover again the process that we are using every time we're having a piece of geometry, then we're doing this VDB from Polygon. Uh, then we're using this thing I created that um, scales it um, with a reference high and a reference low. Um, and then we're um, going into the source tab, merging all of those together, merging all of those together. Um, and then in the Pyro solver, uh, loading it in the sourcing tab. Um, there's a source volume that's the name here, and then the target field that's the name there. And then if you look in the output, you can see that because I added that field up into the upfront, I now have that field here to choose from. So I can choose the color field as the boundary. This is just a huge giant field everywhere. And then I have my velocity field as the and the velocity field, by the way, doesn't is very confusing because it has negative and positive values, so it doesn't display things correctly, really. If I were to choose this like vel z, and I'm going to use my density, that's kind of only got positive values. Okay, and then there's this other node. This is volume slice node, and that if you click on that, um, that lets you choose a field that you want to slice. So this is slicing the z velocity field. Or I could choose the pressure field and undo the z velocity field, and this is the slicing the pressure field. That's right. And then you can drag this offset this way, and you can change the X or the Y or Z. You can change it to being a different plane. So if I make this the XZ plane, it's going to be a cross section that way. And then there's different ramps that you can choose from here for displaying it, or a custom one, which lets you set the color this way. So and you can set a custom field custom ramp. A ramp is the name for gradient. And then that lets you enter colors here. Um, and by the way, the reason it looks weird is because if you have two fields here, it will try to overlap them. So you have to uncheck. Now you can see it's showing me the custom ramp here, and I can drag this around and I can set a minimum and a maximum value here. So I could set this to be like, change the range of the display. And that changing the range of the display is also possible here. I can turn on this in the volume visualization. I can turn on this range and I can set a minimum and a maximum. So if I wanted to display temperature, I would want to control what the minimum and the maximum range of the display are by turning on this diffuse range button. And then this is a ramp that lets me sort of control how much of the smoke, a sort of weighting of the mask out some of the values, like that. Okay. Okay. Let me play this forward a little bit so I get more stuff. Then the other thing that I can do is I can use the field of the wind or the air to drive particles. Okay, so I can insert some particles into this situation, and it will and use the background forces to drive them. Okay, so just just a little bit of sort of background information in order to understand that. Um, if I let's say I'm just going to do something random here. Um, if I make a grid node here and I turn this on, um, and then I do something called I do like a scatter. Okay, is one of the ways I can add points, get a bunch of points like that. And so this um, if I just type if I type solver, there's a generic solver in Houdini. You're not going to use this. I'm just illustrating something. Okay. If I put these points in here and I go into the solver, you can see that what it's doing is it has the previous frame is the input, and then the output is going to be the next frame. So if I were to say like, if I were to put like a VOP here, and um, I would say take all of my points and add a constant uh, value every and put that here and then output that to the points. Um, and then I were to play this, it will be adding a constant value every single frame. So what it's doing, what all these solvers do is they insert some conditions in they you're never going to use them, just showing you like the idea is that it's taking the previous condition, doing an operation, uh, and doing something, and then inserting that into the start condition on the next one. Okay, so when you're doing like a particle simulation, what you need to do is first create some points. And what you can do to do that is I could take, I think, um, I think I took the air volume here. Yeah. So this is the volume of air that I created. If I go up here, you can see there's this volume of air. Remember, I said you needed to model the interior volume, taking this volume of air, and uh, then I did put it in a null here, so I can bring it down here, and then I'll do a VDB uh, from polygons again, put that in there, and then I'm going to do a points from volume. And if I turn this on, I get like a bajillion points. I can do those like, change the spacing of them. And that is different, okay, than doing a scatter on this box. If I did a scatter on the box, I would only get points on the outside. So there are really two ways to make points. One is with the scatter, the other is with this. I mean, there's other ways of doing it, but uh, I made a um, I made a VDB, and then I did a points from volume to scatter points on the inside. And you can drag up, the jitter and sort of randomize them like that. Okay. And then what you can do is you can do a pop network, and you can drag the particles into the pop net. Okay, and a pop net is just like the simulator for Pyro, but it is a little has a little bit of a different setup. It looks like this. Okay, so this is where it's storing the points. This is where it's sourcing in the points. This is the solver, and this is the output. Okay, so I think what you can do is uh, you can do a pop advect by volumes. By the way, this is already set up, right? So I'm just showing you how it works. If you go over here, it's set up right here. So I did a um, sorry, you can do uh here in the pop net, you hit tab um and you do advect by volumes. And then I need to choose this the source. So it's called an SOP. That's irrelevant, but it's just the type of node. It's asking me to choose the source of the node. So I would click here and I would choose my uh, uh, pyro output that I named pyro output, and then I want to choose the name of the field that I want to use to move the particles by, basically. Yeah, no, you can't download it. It's
What happened to me earlier? You have to like click interlink again from like report. It's like somehow refreshing. Yeah, it's like get someone to share it.
here. I can duplicate it. It's called um uh what is it called? Is that what it's called? What does everyone have it called as? I don't see I don't see it either. Somebody maybe deleted it. Okay, let's I'll put it up again. Uh Here it is. I'm putting it up again. Okay. Okay. It's there again now. Um and then this is going slow, I apologize. Um Inside the pop net, okay, you need to um all right, this is so slow. My computer can't handle the zooming and the 8 Rhino windows I've opened. Um, in the source, okay, there's this admissions thing, and usually when you create a pop net, it just makes its own points. So you have to change it here uh, to all points when the default is scatter onto surfaces. Um, and then you can use this pop advect by volumes that I put here. And you can see I chose the pyro solver and then I entered the field name. Remember, the output of the pyro solver is got all these fields, and I have to know the name of the field in order to do it. But if I want to see that, all I need to do is click on the pyro solver and go to the info tab. If I was letting this run. Um, all right. You know what? Let's take our break because my computer's crashing. And then like we will start I will try to get my computer running again. And then we will resume. Okay. Um, okay, so yeah, I would go if I here's my collision behavior. Okay, I can go down here. I would go to click on the source, select the collision source, and then this is what determines how the particles behave when they collide. So I don't know. It's just the same as with other types of programs. These settings they don't mean very much. Bounce basically, if you think about it like uh when something hits something, it bounces back or it gets stuck or it deflects. And so the bounce forward is the kind of deflection. The bounce is the bounce back at you, and the friction is the degree to which it gets stuck. Again, I don't think any of these things are going to be um, uh, matter because we have the air is going around the collision, and actually this might make it more confusing. But if we're getting particles getting stuck in ways, if we're trying to make arrows, maybe we will need to do the collisions. So I turned, you can see I made them bounce very much and I turned down the friction because I didn't want things getting stuck on the surfaces. And then if you bring that into this merge node, it'll happen like this. It'll come in backwards. So if you click on this merge node, you actually need to reverse these in order to get it to collide. Um, because of this left input affects right input. And that should this is sort of as far as I think we need to go with particles. There's other tons of particle simulations you can do, but unless you have a particular goal, all I was trying to do is uh, get the velocity field to display. And you can then use this particle trail uh, thing to display the trails of the velocity. So if I turn this on, that is um, that is how I am getting the velocity field to display. Now, there's a couple of other things going on in here, which has to do with the spawning of the particles, like how you can see in my simulation, they are all um, they're just spawned once, and then they're sort of vanishing. They're sort of just moving throughout it. And um, I think if I remember correctly, um, yeah. Okay. So if typically the particles will come in, they'll come in every frame because this is dynamic simulation. So it's like the previous frame. So if you set up, if I this controls the birth of the particles. So if I were to do this from scratch, let me go back to the beginning here, um, and make a pop net here, uh, and go inside of this, turn this on, change the source again to all points. And then if you go to the birth here, it'll just say one. So it's like if I play this, I don't know if it'll crash, but if I play it, oh, I gotta do a advect uh by volumes, and select my SOP here, my Pyro solver. Let's see if this works. Yeah, look, okay. You can see it's basically every frame bringing in new uh uh particles from the same position that they were previously. And so yes.
Can you explain what the pulp advex by volume does?
Yeah, so uh I don't know if I been clear enough about all the different things that are going on here. I guess uh there's so much going on. I don't know if I can articulate all of it, but um all I'm trying to do is make arrows, right? So in order to do that, like we need to use a different type of simulator. And that is like a particle simulator as opposed to the fluid simulator. So the particle simulator is very different in the sense that it just creates a bunch of points and then it moves them. And the way it moves them is um, there's innumerable ways to move them. I can move them just by giving them a volume every frame, a velocity every frame, or I could move them by a force, like I could add a gravity force to them, or I could move them uh, by a field. And so, like, because we already have a simulation set up that's using the air, that's already moving the field for the air, we're the the way we can move them is just with the previously existing field of the air. So, like, basically, I don't know if it makes complete sense to you guys yet. I hope that it will make sense eventually, but like basically, we have a like a gridded universe of in 3D, but this is in 2D. So we have a gridded universe, right? Um, and at every point, there's a velocity stored in three-dimensional space. And so that is the velocity field that exists inside and so all rather than having like all these particles move according to some new force that I'm adding, all I want to do is have them move using the air that I've already created. So we don't do, I talked about this once, we don't do air simulations with particles because air is incompressible and particles, they don't like they're all dispersed at different distances from one another. And so if you were to try to simulate air with particles, you would need infinite particles in order to keep them from, or you would need like very complicated collision behavior in order to keep them always the same distance from each other. Actually, air is uniform density. Like when I move my hand, I'm not brushing air particles. It's always it's so fine grained that it's uniform density around me. And so rather than doing a particle simulation for air, I can treat air as though it's a constant field and I store the velocity values at every point. Um, so this all I'm trying to do is move the air particles by the velocity field that I've already created. In terms of what is a velocity field and why do I store it this way and how do I store it, that's the mathematics of it. I that's what I'm going to go into now, but I want you to be able to use it. Uh, I think it's more fun to be able to use it before I spend time talking about what it is. So like, but basically it's a vector field, and a vector field is just a vector at every point in space. And then I insert some particles in here, and they get moved by the vector field. They get advected. The word is advect, moved by a vector field. And so, like, actually, I don't know why the vector field self affects. Okay, so like the vector field moves itself, and then it also moves the stuff that's in it. If you think about it like if you think about it like this point of velocity, one frame over now impacts this velocity. So the velocity field impacts itself, and it also moves stuff within it. And so like uh, um, the I am using the pop network, the pops in Houdini. Remember, I said that so in Houdini simulations work. Simulations always work. You know, always uh, either time based or we haven't talked about the convergence style yet. But like basically, whatever the state is here, it evaluates that, and then that's the new state, and then it evaluates it, and then that's the new state. So this uh, the pop network, just another version of that that works on particles rather than working on vector fields. So basically the pyro simulation is a simulator on vector fields. It just has a stupid name, but it's basically a vector field simulator. The pop network is a particle simulator, and you can have them interact with each other by using the vector fields to move the particles, or you could have them not interact and move them with different forces. But because we're not interested in particles, we're trying to simulate air. We're using the this advect by pop advect by volumes to select the field that we already have and then move the particles with it. So this basically the way they work is they bring in the source every single frame and they do a bunch of things on it. So if you have the particles coming in, they will spawn every frame forever and ever and ever and build up on top of themselves and get super, super dense. Or uh, you can do change the impulse activation so that it only happens once. And the way to do that is you can do a dollar sign frame is less than or equal to one. Okay. Now, what does that mean? Dollar sign FF. I don't use BEX, which is Houdini's scripting language, except for these two commands. One is dollar sign time is the key sign for time, and the other one is dollar sign F. Okay, and that's the key sign for frame. Dollar sign FF takes into account the sub steps in the simulation. So if you remember, like the we're simulating not every frame, but actually like multiple times a frame. That was controlled. Um, uh, that was controlled in the solver. The sub steps in the solver. I have it set to 2 here. So we are this takes into account the sub steps in the frame, the $ FF. So if you say it's uh, only activates the when it's less than or equal to 1, a little confusing, I have to say, but that's because the 1 in the impulse activation is means yes, and 0 means no. So like um if you put uh an expression in there, that means the frame is less than 1, less than or equal to 1. So if it's less than or equal to 1, 1, true, yes. If it's greater than 1, 0, false. So it will that's how you can get it to activate um, only on the first frame. And then here in the particle trails, there's all these sorts of settings, the length of the particle trail, et cetera, whether it has an end or not. Um, but it doesn't really matter. We could also spawn them, less of them and spawn them continuously, and then it would, be a different way of representing it. But that's not what I did here. So I think this is the way that we can represent essentially like a vector field. Okay, and then um I also added some arrows here, but I'm not going to go through it right now. Okay. So the only things that I've talked about today so far are using spawning particles, um, and then basically changing the bounding box in the pop kill so that uh, they don't build up forever and ever and ever outside of that. And adding the particle trail, and then also the file cache and uh, the flip book. I feel like those things um, are sort of the back end and all the volume visualization thing. I feel like those are the back end of the simulation that we can start to do in order to look at them and save them. Okay. Um, okay. Now I want to look at a different one. Okay, which I uploaded for you guys. It's called um, uh, this one, temp stack revised. It should be called temperature stack. Let me just make it the same. Temperature stack revised. Okay. And this one is I keep making these and changing them, but I think this is the most clear one. Um, and this one, if we open that, um, it doesn't have any geometry that needs to be loaded. It should just work. Okay.
There's like a correct and sparse and legacy, not
You don't see this?
yeah.
This one is okay too, probably. No, this we let's um nobody sees that.
Oh, definitely see that.
Okay. Um so Yes. A question?
So into that being how it works in terms of like you use something with the blue it's on, but then like I don't understand the logistics of playing the simulation, and then I go back to the beginning, but then is it loading it again?
It's
Is
a
that
really good question. Yeah. So actually, I screw this up all the time. So, like, if I one of the reasons why your computers maybe like they so basically if when everything is set up, okay, um, when everything is set up, and I uh um play the simulation, like I always like if I go back to the beginning, and I play the simulation, it sort of works well, okay? But then if I change something, like this will turn orange, and that means like it's all dead, like it's not real. And what you're seeing on your screen is like an old thing that is no longer accurate. And so then if you try to change the display to a different node without resetting the simulation, sometimes it'll hang up because it's trying to calculate like you're trying to figure out the 83rd frame of a simulation that you haven't like baked into memory yet. Does that make sense?
so? But so like for example, I have a blue bar down there. You have blue, so that's like what blue is what's been loaded into RAM.
That's correct.
So like to the beginning button, which is the far left on the little player down
Yeah.
there, and theoretically it's not going to go super slow. Like that's what I'm confused about. It's like it seems like it's loaded, but then when you go to the beginning and play it again, it's like feels like slow and lively. But I don't know, maybe that's
Um, yeah. I let me see if I can uh clarify that. There's a way, I don't remember how to do it. Where you can determine you can turn off the RAM cache. Forgetting how to do it right now. Basically, I don't like it's trying to load a portion of the simulation into RAM. But depending on your computer, it can load more or less into RAM than that depends entirely on your like how much RAM you have. Uh, and also there's a way to control how much uh RAM is allocated. Which I'm forgetting now. But um if I were to go in here and like, change something, like, it'll turn orange. And now it's like that is fake. It's telling me the orange is just I don't it's just telling me that it's whatever I'm seeing on the screen is no longer real. And so like if I try to play this now, it's gonna hang up because like it's trying to play from the 31st frame something that is not actually it no longer has like set up. So it'll try to figure out in the background what the 31st frame of the simulation was. So it will like sort of without showing it to you, try to load the entire simulation in the background. So when I change something, I will always kind of click to the beginning again, and then at the first frame it should play normally, but it will be slow, because it's trying to load that into memory. Does that make sense? I don't know why uh like yours is playing slowly when it's already cached into RAM. Uh it should play fairly quickly when it's cached into RAM, I would assume, is it not?
But
Um,
article, article part was playing extremely fast. They were just shooting out and disappearing like in a second. And then I tried to do it with the pirate solver, and then it's
so what was happening before, like if you have like if you try to here, like let me see if I can get it to happen. If I go here, okay, and then I try to like if I were to try to like load, if I were to try to fill this with particles now, it would be very likely to crash because it would be trying to advect the particles based on the history of the velocity field when it hasn't sort of done that every single frame. Like, so I think when you add something sort of heavy or when you change it, it's usually important to like reset the simulation. Um, so that it can sort of, but usually also like if I were doing this, I don't know. I happen to be like a very messy computer user. Like I always do things in a stupid way. But like if I were doing this, like I would never, if I were being serious about it, I would always put like a file cache in between one simulating engine and another. I wouldn't try to like set up the pop simulation while the uh pyro simulation is also still running in the background. I would always like finish with one simulation, file cache it, and then add the next sort of layer on top of it in terms of display. Um I the other thing I is that um all of this is very dependent on the uh the substeps and the voxel side. So um like depending on your computer. Also, by the way, this checkbox, the OpenCL, kind of makes it run a little faster. Oh, here it is. Look, there it is. You can disable the cache into RAM right here. That's how much RAM is gonna be, it's gonna store, right? So you could increase it if you have a very good computer, or you could decrease it if your computer is gonna screw up if you try to load a huge simulation into RAM, right? So like if your computer's sort of slowish, you can uncheck the cache into RAM to save your RAM for like other things, right? If you have a super fast computer, you can have more of it load into RAM there. But either way, like you can lower these substeps to something to just to one, and you can keep the voxel size low. Um, the other thing that's happening here, if you look through this, is there's every time I create a volume, there's a voxel size, okay? Like there's one here, there's one here, there's one here. They're everywhere, okay? And what I have done, there's another sort of thing you can do, okay, which is you can go here, you can right click on something, and you can go copy parameter. And then like I have here in the this VDB, I went over here and I said paste relative reference. So this is telling me that the voxel size here is updating when I change the voxel size here. So this is something that is always done, like all over. I've got 7 bounding boxes. I've got 7 different voxel sizes, and I can decide to control them in one place by using this by going copy parameter and paste relative reference. So I have to say, like, I don't know. I don't have a good answer for how we can get our simulations to play faster. I think it's just like nobody can, right? Like it's just it's super annoying. Like we just have to keep them low resolution while we're trying to set them up. And then before we file cache it, increase the resolution, increase the substeps, and file cache it, and then do the next step. Does that make sense? Okay. Um, so um, what I wanted to do here is like um, this is like a slightly different workflow, but if I play this, um, like oh now you can see like it's going. You see those little jagged marks? Those little jagged marks are because I decreased the substeps, right? So like if I pop this back up to higher, those little um you can see it smoother. You don't see the little steps anymore. You can still see them a little bit. Okay, so in this simulation, what I've got going on is I've got cold smoke flowing in the floor, hitting a heat source, booming up to the top, filling up the box, and then meeting in the middle. And so I think what I was doing previously uh, is I just had a temperature source and then I had a smoke source and I was just using the smoke to sort of be moved with it, right? Now I'm like imagining that I'm in blowing blowing smoke in that's cold. I might blow cold air in, blow hot air in from different sources, and then see how they mix, right? So I feel like in the way these two things are working, I feel like they're sufficient sort of to describe uh, the air motion. The one thing that I haven't shown you how to do yet is uh, which I probably should have done before I did this, is to add a velocity source of your own accord. Like all I showed you how to do, if you remember, like a long time ago, in the original time, the first class where I talked about this is I just said you could go into the Houdini solver and go to the shape and just add wind. Click on the wind and turn off the buoyancy. That'll just blow wind in like it's a wind tunnel, like from one side. But if you don't want to do that, like if you wanted to like let's say have a window or something or a particular spot where you're or like a fan where you're like blowing from rather than imagining the whole thing as though it's inside of a wind tunnel. You can do that very easily, but what we can't do anymore is do this the simple VDB activate from polygon thing because that so like what we would need to do is um by the way, the reason I want to go through the simulation with you after I finish this sort of detour is that I um played with the settings a lot to get it to look like that. Okay, so like adjusting the buoyancy, adjusting the the speed with which things are heating up and slowing down. So like it's basically the same as everything I've done with you previously, but I spent time, you know, messing with the various rates in order to get it to seem like it was behaving appropriately. Okay. But in order to create a wind source, okay, I'm going to add a wind source to the middle of this. Okay. So in order to do that, I'm gonna make a box, uh, just like no, I've done in the past. There it is. Let me update this by make it large or something. Uh, okay. And then um, I'm going to just do something here. I'm going to do a VDB. And this is like an empty VDB, just an empty blank VDB with nothing in it. And I'm going to change this. It's going to still be a fog volume, but instead of a float, I will make it a vector float. And then instead of a color, I'll make it a displacement velocity acceleration. Okay, and so this is the reason you can't do it the normal way, okay, is because uh uh if you think about we've been looking at fog volumes, and the fog volumes are uh they're floats. So a float is the word in computers for like a decimal value, a real number, like zero point 0 whatever. So a typical fog volume is storing at the center of every cell a single value for a single float, a single number for the density or the temperature or whatever. But if you want to store a velocity, you need a vector. Okay. And you can change, you need to create it in different ways. So you can do this fog volume, and instead of it being a typical float, you can do a vector float. And then uh, we need to tell Houdini what kind of value it's going to be, and that will be displacement velocity acceleration. Okay. And then you can do a VDB activate, um, which and go over here and check this, go to this reference tab instead of these other ones. You turn on the reference. And then this activates a velocity. This it still looks the same, but it's not. It's storing vector values instead. So what I would do here is I would go then I need to make something that will add. Right now, all these are zero. Okay, they're set to this they're set to this background value here. So if I set this value to like I don't know if I set it to 25, okay, and then I do a points from volume, and I can do a velocity. Uh, I can do this volume trail. And if I put the particles in here and the VDB in here, and I look at this, um, no, it's not doing anything. I don't know. Okay. Oh, there's only one point. That's why. Uh, you can see there uh, are um, this. Well, it's very hard to see, but this little setup here is showing me. I've just given it this value here, but it's kind of now there's no value. I give it a background value. It's shooting up. It's very hard to see, but this is trying to display the vector values at all of these points. Okay, so in order to control this, I can do I need to give this a proper name. So let me give it let me name it. I'll call it velocity. And then I could do, well, I'm just gonna, because I don't want you to have to do it. Let me open up my old one. Um, uh, this little thing right here, this volume bob. that you can copy and paste will take that vector and let you give it a value. Okay. So like if you go in here, all it's doing is like giving it a value. Okay. This, I can set this is negative 25. And then if I did my particles, uh, volume, points from volume, uh, and I do a volume trail. You can see the vector. It's kind of hard to see, honestly, but it's trying to give it. This is not working because, again, I have to go in here and go to the bind export. This is set to V. So if I change this to velocity, based on the name that I gave it, now you can see. So, um, there it's assigning a velocity volume. Okay, so this little thing in the old Houdini over here in the other file that I made us leave, that's this little thing here that's loading in a velocity. So it's the same type of source as always, but there's a slightly different setup, which is rather than doing the VDB from polygons, you have to activate the VDB in a different way, and then you need to assign it a velocity. And if you would have to go in there and change the name again based on the name that you assign it. Okay. So then if I go into my where I just did this over here, if I call this let me make this if I call this null, oops. I make a null and I call this velocity source. And I merge this. Oops, I've already got it. I merge this into the other inputs of my pyro solver. Um, and then I go into the pyro solver and I go to my sourcing and I go, I have this velocity here. So before I had none, but I could call this velocity because that's what I called it. And it's coming into the val field. Okay, and then this is adding it every time. So that's sort of pretty intense. Maybe I'll do like, let's just add it every time to see. Okay, and now I will go back to the beginning here, turn on my volume visualization, and let's see if this works. Okay, I have this big wind in the middle, so when stuff gets there, it should be blown, should hopefully be blown to the side. Nope, not getting blown. What did I do wrong? Oh, I have the volume trail rather than the thing. Look. Well, it's going all crazy, right? But like it's there's wind blowing through that box.
Can you go over again what you did? Like, yeah, you flipped something like just before this.
Right before I got this working.
Yeah.
Oh, I had the volume trail going into the source. And that like is not what that's just this thing I was just trying to display. Like, so you don't need this. This is just me looking at the
Put into immersion. It's not a volume control.
I need to put the so this that is just to display the velocity. So what I did is I needed to make a box, I needed to make a blank VDB, and then I needed to activate them. And in the activation, I had to call this, I had to name this, I need to name this velocity. So I created several, let me make this big. Uh I created it's just slightly different than all the other things we've done up till now. Like all the other things I've done this VDB from polygon, VDB from polygon, VDB from polygon, VDB from polygon. So this one, rather than just putting the box into that, I need to make a blank VDB that was vector float, viscosity, displacement, acceleration, and then I needed to activate them. And then I added this, I created this node that adds a vector, and then that node just goes into the velocity. So what we will do, what we are doing is three things: smoke sources, temperature sources, velocity sources, and collisions. Four things. And those things together with the settings tweaked should be able to simulate any type of environment. And so then in the Pyro solver, basically, you just have as many of these as you need. You just merge them all together in this one component, pump it in, and you just have as many as you need. And they source into the correct fields with the correct type of adding. And the question is, only keeping track of the name, making sure you don't get lost with the names. And I've given you all these, I've given you these volume bops. This one that sets a vector. This one that scales to based on a this one that scales based on a high and a low reference temperature. You will see in this high and low reference temperature here, what I did is I went to my setup. I went to my fields, sorry, to the buoyancy, and here's the ambient temp and the reference temp. I went copy parameter, and then I pasted it in the reference low and the reference high. But if you delete channels, you'll see what it's supposed to be, which is giving you this node that scales something between 0 and 1 based on a reference high and a reference low, so that we can match the way the temperature sources in the Houdini. And that should be that should be everything, I think, that we need to get things functioning. Okay. Now in this one, I'm going to get rid of this source and go back here. In this one, like it took me, what I was concerned about, okay, was trying to get smoke to uh, go along the floor like this, to sync. And so I think um, I'm actually a little worried that it's going to be confusing. I kind of wish I had done it in a different way. But like I set up these sources slightly differently. I don't know if that's going to be confusing. Because rather than like in the old version, in this version, I had different sources for smoke, for heat, for wind, and um uh um for smoke for temperature. And that's fine. I don't see anything wrong with that. It seems totally um a viable way to do it to me. Um, but in this one, I did do it slightly differently, and that's because uh, I just wanted to show one other way of generating a volume, which is the only other way that you would sometimes generate a volume. And that is you can generate a volume from points. Okay, so like what I did here is like I made, let's say, like a grid. Um, Something like that, and you can drag up the points in the columns and um, like something like that. And then you can do like a pyro source, which actually is the same thing as like a scatter, by the way. It's just has some other values. So actually, I could just do a scatter um, and get a bunch of points on it. Um, and then you can do this attribute noise, and that uh, like generates noise based on those points for the name of an attribute. So if I wanted to do density, I would make this a float. I would call it like density, and then I could um, I think there's a you can click this little visualize thing. Um, and
Is a question. Is the
yeah,
noise added in the same plane as the grid, or it's like
it's just adding like an attribute to the points.
oh, it's
So
like separate from
it's
the
like adding a named attribute to the points.
oh
And then you can go like you can do it again. You can do like um um you can do this volume rasterize attributes. And that will you can name the attributes that you want to rasterize. So this has density, and it'll like make a volume from the attribute of the points.
it turns each point like a box of
That's right. Into like a cloud of voxels, basically.
wow.
Yeah, like it sort of makes a puffy cloud around the points. And so yeah, so that's why it's better to use this like if you look at it like um it's sort of that's why it's better to use this pyro source. But yeah, you can see, right? Like they do. It's sort of like you have to scale it based on they do overlap. They like either are kind of very sparse or they sort of influence each other, right? So you can kind of make a um and if I go in here, by the way, and I click this animation, you can make a kind of like a vaguely easily animating cloud of inputs that way. And so like I could Um, you see, right? Like you can sort of make a source that is not, it's kind of an easy way to make a moving source, like a sort of a non-static input source. And I could use that instead as a, if I um one thing I can do is like here, by the way, um I don't know. It's a little confusing. I'm out of time, so I don't know what to do because like um all all I'm saying is that that is a possible way of like you could use that as a density source instead, and then it's just an easy way to set up so that it's not. There are other ways to add noise, but this way it's just not going to be a right like a tube. It'll be like a more moving moving source, right? Okay, so then in this file, I just want to briefly say what I have here, which is that this adds a density and it adds a temperature the same way, and then this little thing adds a velocity with all these noise attributes here. This is the velocity. If I go in here, the vector is there. So this is uh a smoke. This is a cold source and then a heat source, which is around this box in the middle that has it has this uh it has this um uh I did a volume VOP here to this volume VOP that I gave you, which gives it a value. I gave it a 500 value, and the reference level is low. So what took me a while in this simulation is just defining these relative reference values. Like in here, in the buoyancy, um, in the buoyancy tab, this is the low temp, that's sort of the zero value. Anything at 290 will not sink or rise. Anything below 290 will sink. Anything above 290 will rise. And then this is the high point of the simulation. We cannot input temperatures higher than that. So defining that sort of took a little time. And then also setting the buoyancy scale so that it makes the simulation work the way I want it to. And then also um, these source volumes, uh, I needed to decide the acceleration strength and the deceleration strength of each one. So, like, if I have like a box, I have a little like area around it that is like hot, but when air hits it, if that acceleration strength is very low, it'll just stay cool and move through it. So like the acceleration strength is only viable for this pull. So sort of setting that to be right and deciding whether things are going to uh, um, be a maximum or a pull. Um, and then you'll see also, I had a sort of a background temperature just to start things off. But I wanted to deactivate it after the first frame. So it wasn't doing anything. So I did this $ FF that I did previously. So to try to set that up. So the scaling of the fields to get it to behave appropriately was sort of the hard part. Okay, I'm out of time. You know what I'm going to do? I'm just going to record a tutorial of this one um, on video because I don't want to spend any more time in class actually like doing it in front of you. I feel like you need to try things. I need to work through things with you. So like I'm gonna move on from like in-class tutorials of this, but this one I ran out of time, so I'll record a video for that. And then I think next class I'm either uh going to uh I think it would be good to like have a chance where I can kind of go around the room and look at things with you and see what you're working on. So I think it would be good to try something like that for next class. But if you're not there, we'll do it the following class, and I'll do the math the next class. That's my plan. Okay. So um, I don't know what your situation in studio is like, how painful it's going to be this week, but I would like to do it next class. But if we cannot do that next class because nobody's got anything, then I'll just do math with you, and we'll do it the following class. Okay. But that's sort of the plan. Okay. All right. And I think in terms of the wind tunnels, I got to order some bolts, and then next step also for next class. Okay. Great.